So welcome you all to the week 2 problem solving session of Advanced Calculus for Engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical systems. In today's session, we start by recalling the limit and continuity definition in one variable. Then we extend the definition to the two variables, and then we introduce partial first order partial derivatives and higher order partial derivatives, and we also do the problems on these topics. So let me start with the introduction or recalling this limit definition in one variable. So if we say that limit x tends to x naught, fx is L, what is that meaning? Can anybody tell me?
Sir, as far as um, x belongs to in the delta neighborhood, the function fx belongs to epsilon neighborhood, where delta is connected by epsilon.
Good. So formally, let me write it. Then for every epsilon greater than 0, there exists a delta greater than 0, and please remember this delta depends on epsilon, such that fx minus L is less than epsilon whenever 0 is less than x minus x naught less than delta. We only talk about the deleted neighborhood. We don't say that x naught is achieved, as we are talking about the limit and we are not talking about the continuity. You will feel the difference when we talk about the continuity. So how pictorially it will look like, let me draw that. So suppose this is your fx and suppose this is your x naught. So what is this meaning? This is meaning is that you are deleting this point. You are not including this point, but and corresponding to this point, suppose there is some limit L. This is L. So as we said, for every epsilon greater than 0, that means first of all we need to consider some epsilon greater than 0, and this will be the neighborhood of this L, and the corresponding delta you will get, this is x naught minus delta, x naught plus delta. Regarding this neighborhood, whenever you talk about this neighborhood, your function will stay in this neighborhood. Let me just redraw it in some sense so that it will look like that, what I am saying. So this is your then epsilon, and this will be your x naught. So your graph should go like this. So this is your neighborhood. So whenever you're taking a neighborhood on this y-axis corresponding to this neighborhood, you will get a deleted neighborhood. That means you are excluding x naught on x-axis, such that this fx is approaches to this point L. So this was about in one variable. Now there is one another definition that we use for the calculation, that is LHL, left hand limit, RHL, right hand limit. I hope everybody remember because we have done this in the last class. So whenever this LHL and RHL are equal, we say limit at x tending to x naught exists, otherwise it does not exist. So this is in the one variable. Is there any motivation that you are getting how the case will vary in case of two variable? I mean, how the things will vary in case of two variables? Any intuition? Any guesses?
In this case, we are approaching to two possible ways in a plain 2D, I mean 1D graph,
Yes,
basic curve, and in 2D it will be a surface. So for a point, we will reach through infinite points, like in a circle, like a small circle, and from every point of a circle to that point where we are finding limit.
correct,
So
correct.
infinite ways.
See, now let me explain it. See here, you are approaching, you can approach x naught from left hand side or from right hand side. There are only two ways. But when you talk about any point x naught, y naught in 2D, suppose this is your xy and the point x naught, y naught is here, x naught, y naught. Now, what will you say about the neighborhood? Earlier, you know that the neighborhood is can be approached from the left hand side, right hand side, but you have so many possibility to approach this x naught, y naught. So what we do, we consider two possibilities. One is to consider an open ball as neighborhood, and again I am saying here is also a, it is also a deleted neighborhood. This is your x naught, y naught, and this distance is your delta. Then we will write precise definition of this limit in two variable case. And another possibility is, there is one another way to write this neighborhood, is that we consider this point x naught, y naught, and this will be some square, you can say. Just we need to take any around neighborhood of this x naught, y naught. It can be in the form of circle or it can be in the form of square. Preferably, usually we do in case of by taking circular neighborhood. So this neighborhood is like this. I am talking about, again I am saying deleted neighborhood. So I am lighting greater than 0. So this point is not included. I am making it red. So this point is not included. Similarly, this point is not included. So this will be square plus y minus y naught square less than delta for this case. And for this case, we will say that x minus x naught is less than delta and 0 to y minus y naught less than delta. So this was about the neighborhood, how in two variables you see the neighborhood. So let me write the formal definition. So limit xy tending to x naught, y naught, so it can be written as fxy if it is equal to L, then again in the same flow we write for every epsilon greater than 0 there exists, let me write it, there exists a delta greater than 0 such that how things will change, that fxy minus L is less than epsilon whenever 0 less than under root x minus x naught square plus y minus y naught square less than delta. Either this can be the whenever condition, or whole statement will be same, just the difference is this: whenever 0 minus x naught is less than delta, and simultaneously 0 less than y minus y naught is less than delta. Is it clear? So this was the formal definition of epsilon delta definition, we call it, of limit. Now observe that, let me make a note here, that note that limit of a function at point x naught y naught is unique, but the condition is that if it exists. It is also the case in the one variable also. The thing will be replaced by only here x naught rather than saying x naught y naught. So limit will be unique, but the only thing is that it should exist. Okay. Now in the previous case, in the one variable case, how many ways to approach, I'm again recalling that thing, how many ways to approach to x
Two
naught?
ways.
Two ways, correct. So we know that here it is two ways, left or right. But in case of circular neighborhood or in case of rectangular neighborhood,
Infinite number of ways.
infinite number of ways. So in case of two variable, we are quickly calculating LHL, RHL and saying if they are equal, then we can obviously say that limit exists or not. But in these scenarios, it is not like that, because whenever you try to approach this point, you can approach by this, by some y equal to x curve, by some y equal to x curve also, y equal to x square curve, anything. There are infinitely many, so you cannot maintain here kind of some LHL or RHL, you can say the things. So here what will happen, if you want to prove that limit exists or not, so there is a strict restriction that you need to follow this epsilon delta definition. Okay. But when you want to say that limit does not exist, for that case scenario, you can choose two different paths so that you can say the limit does not exist. So let me tell this thing by two examples. In one, we will show that the limit exists, and in one, we will show that the limit does not exist. So these examples were included in the lecture also. So I am just quickly picking up them from the lecture. So obviously all the other properties of limit holds in this scenario. I hope that is not a problem. You will do that. So let me write example first. Show that limit xy tending to 0 0. The simplest example is this: x plus y sine 1 by x plus y is 0. So any idea how can we show this? See, we consider the above definition. What we need to show that? We need to show that fx minus L is less than epsilon whenever our neighborhood is less than delta. Deleted neighborhood is less than delta. So we consider fx y minus L. So what is
We can
fx y?
also substitute, sir, for x plus y is equal to t, na?
Yes, we can do that, but you have to maintain what is x, what is y. There are parametric form. I'll let you know that approach also. Just let me first make a clear note how can we apply the epsilon delta definition. Okay, so
Right. You are showing using directly from definition, not
yes,
other ways.
yes, exactly. For the time being I am showing only via definition that we have discussed till
But
now.
it can be done without using definition also.
Yeah, in some scenarios I'll let you know also that. So let me just first
Okay.
complete this one. So x plus y sine minus 0. Now you know that this thing can be written as mod of x plus y sine 1 by x plus y. Now tell me, sine theta is bounded.
Yes, it is bounded.
So it is bounded by
Bounded by
1
zero,
because
one, maximum one.
yes, because mod of sine theta is less than 1 for all theta. Okay, so you got that this is mod x plus mod y. Okay, sir, one more thing I want to make it clear that whenever we don't write this left hand side here, here and here, then we maintain what is the relation between the last line and the this line, next line. So you can observe that here it is the equality relation, and when you apply the triangle inequality and this inequality, this will become a inequality relation. But what is the relation between this line and this line? Obviously you are just solving them. So here the symbol is equality, not inequality. Overall we can say that fx y minus L is less than equal to mod x plus mod y. But here, since we are not writing left hand side, so we are just making sure that what is the relation of the next line with the previous line. So that was just out of the box suggestion. So now let us come back to the main thing. Now we know that our delta should be lie between the deleted neighborhood. What is the deleted neighborhood will be in this case? It will be 0, x minus 0 whole square, y minus 0 whole square is less than delta. So it can be written as 0 under root x square plus y square less than delta. Now one can easily observe that, can I say that this mod of x is less than equal to under root of x square plus y square? Can I say this? Tell me.
Yes,
For all xy?
yes,
Okay. Similarly, mod of y is less than equal to under root of
Yes, sir.
x square plus y square for all xy. Okay. So using these two and using our equation number 1, can we say this that fxy minus L is less than equal to 2 times of under root of x square plus y square. Clear? Now we know that by this star equation, this thing is nothing but less than delta. So you know that this thing is nothing but less than 2 times of delta. But what you here want? What you want here?
Less than epsilon.
Less than epsilon. So what we will do? We will very smartly choose
2
delta
delta equal to epsilon.
epsilon by 2 so that it will be less than epsilon. Okay. Therefore, fxy minus L, this will be less than epsilon whenever 0 less than x square plus y square is less than delta. And what is delta here? Where delta is equal to nothing but epsilon by 2. If we are able to show like this, then we can guaranteed say that the limit exists. But what will be the case if we want to show that that limit does not exist? So as I told you, there must be two different paths on which we can guarantee that that limit does not exist. So let us do that example also. Example number 2. Check.
Showing that limit does not exist is very easy than showing limit exists.
Yes, obviously.
Yes, sir.
But in some case scenario, showing that limit does not exist is also a typical, because you don't know the two different curves. There are some those example also. So but that will be exceptional cases. But yeah, obviously showing the limit exists is quite difficult than this one. So check whether the limit exists or not. So I'm talking about limit xy tending to 0 0 x square y divided by x to the power 4 plus y square. So can anybody tell me what can be the two different paths over which I can show that this limit does not exist?
Y equal to x square.
Okay.
Y equal to x square. By m x square, sorry.
Choose y is equal to mx square. Then, if the limit is
Wait, wait,
independent of
wait,
m,
wait, wait,
then we can talk further.
Wait, wait. Let us not go to the general method. First of all, I'm just asking um, degree of numerator is smaller. Okay. That will also a point. So I'm saying what we will do, we will go by basic, then we will generalize it by equal to mx. Okay. First of all, we will choose simply two curves. So it can be y equal to x and y equal to
X,
x square. Okay. So I'm saying first of all, I'm moving along y equal to x. So you know that limit xy tending to 0 0 simultaneously. So if x tends to 0, then y will also tend to 0. So your this case limit xy tending to 0 0 x square y divided by x to the power 4 plus y square, it can be written as limit x tends to 0 x square. You have chosen y equal to x, so it will be multiplied by x, keep x to the power 4 x square. So from here, if you will try to calculate, you will get 0. But when you go around the curve y equal to x square simply, then what will happen? Again, limit xy tending to 0 0 x square y x to the power 4 plus y square, it can be written as limit x tending to 0 x square into x square divided by x to the power 4 plus x to the power 4. What it will give you? Half. So as I told you, if limit exists, it should be unique along every path. So here you have chosen two paths. Here you are getting the limit as 0. and here you are getting the limit as half. What does that mean? Hence the limit xy tending to 0 0 x square y x to the power 4 y square does
not exist.
not exist. This is the basic approach by choosing two paths. Now what is the general approach? General approach is to choose something mx type. Now observe here that your degree here is x square, here is y degree is 1, here x degree is 4, here y degree is 2. So if you want to make all the degrees equal so that your variable will cancel out, what you will choose? Y in terms of x square. What should be the power of y equal to mx square, mx cube? What you should choose?
Mx square.
Mx square. So that
mx square.
yeah, so that degree can be equal. So I am telling you the general method number 2. Sometimes it will not looking like directly what you have to choose in terms of m. That's why the easiest approach to see these two curves or see simple two paths. So now along y is equal to mx square. Obviously here m can vary, m can be 1 2 3 4. So our target is to show that our limit should depend on m, our answer should depend on m. How? Let us see. Y 4 y square limit x tending to 0 x square mx square x to the power 4 m square x to the power 4. What you will get? M divided by 1 plus m square. So as I told you, m can vary. So suppose m is equal to 0. What will be your limit if m equal to 0?
0.
0. And when m equal to 1, what will be your limit?
1 by 2.
At m equal to 2, it will be 2 by 5. So ultimately, as much as you're changing the value of m, that means as much as you're changing the curves. And by changing the curves, the limit is varying. It is not unique. So that means whenever your limit depends on m, that means you can guarantee that this limit does not exist. So this is dependent on m. So again the conclusion is obviously the same as in the previous method, hence the limit does not exist. So I hope you have been cleared how to show that the limit exists and how to show that the limit does not exist. Okay, there is one more way, that is called the polar coordinate, to see how the limit exists or not, that we will do in the next example or in the next question. So let me write the first question. Find the value of the following limit. And what is that? Limit xy tending to 0 0 a to the power x square y square minus 1 divided by x square plus y square. You need to calculate the limit of this function. So the approach that tells you, or the question itself tells you, you have to apply the polar coordinates. What are the polar coordinates? Can anybody recall that?
R cos theta, R sin theta. And obviously sin and cos when comes, squaring and adding is but natural. And we are seeing that x square plus y square. So directly we can write it as R square.
Okay.
Basic parametric form of a circle.
Good. So what are the polar coordinates? These are the, as Manas told, these are the basic parametric coordinates of a circle. So we choose x equal to r cos theta and y equal to r sin theta. This will also help you in future also, this polar coordinate. So if you try to add x square plus y square, you will get r square sine square theta plus r square cos, sorry, I just cos square theta. Could you please mute yourself? Sine square theta. So this will give you nothing but the r square. Now,
কিন্তু আমি একটা ক্লাস হচ্ছে বল।
Vishwajit ji, can you mute yourself?
হুম?
Vishwajit ji,
Yes, sir.
can you mute yourself, please? Thank you. So now we know that our xy is tending to 0 0. So obviously when xy tending to 0 0, where x square plus y square will tend to 0. So your limit function will reduce to e to the power x square plus y square minus 1 divided by x square plus y square. So limit r tending to 0, e to the power r square sorry for the disturbance, let me just rejoin it. So I hope screen is again visible to you. So it will be r square minus 1 divided by r square. Now quickly tell me what will be its limit. Last in the, obviously now it is reduced to one variable. Now it is not in the case of two variables. You can clearly see that. In the last problem solving session, we discussed L'Hopital rule. Is it that kind of case or not? Tell me. Manas,
Yes, it is. Yes, sir.
it is 0 by
Zero form.
0 by 0 form. So what will you do? You will differentiate and the numerator and denominator explicitly. When will you differentiate the numerator? You will get 2r e to the power r square and 2r. So 2r will be cancelled out. You will left with limit r tending to 0 e to the power r square. But you will get, is it clear?
Yes, sir.
Now tell me when um, when will be the case that in that scenario you can tell by the polar coordinate that limit does not exist. Here obviously limit is existing. You can see that it is not depending on any path or anything. But what will be the case when it will say, or it will
Like cos, we will see the cos theta and sin theta term,
yes,
or
we will see
if
our,
something happens like a fixed factor like cos cube x plus sin cube x, like
yeah,
something like that. So we can also use sandwich. We can also go for sandwich.
yes, yes, yes,
But we have to take care of that. It is always bounded or not.
yes. So here we just want to say that consider for limit xy tending to 0 0 xy divided by x square plus y square. So again if you will use polar coordinate, so what will you get? Tell me quickly. When you will use polar coordinate, you will get
Sin
limit
theta, cos theta.
r tending to 0 r square cos theta sin theta and divide by r square. So from here you will get cos theta sin theta. Since limit are tending to 0, so obviously theta will not get affected. So this will be your answer. But here theta varies from, since this is a polar coordinate of circle, so this vary from 0 to 2 pi. Sorry for the disturbance. I hope I'm audible till now.
Yes, sir.
Yes, sir.
Okay. Okay. So here it is depending on the theta. So you can clearly say that since it is depending on theta, so the curve will obviously change whenever theta changes. So you can say that limit does not exist in this case scenario. Is it clear to everybody? Or shall I repeat again?
No, it is
Clear,
all right.
teacher.
Limit depends on theta.
Yes, depends on theta. So as theta changes, so obviously the value of the limit will change.
Limit
Like
will
the,
change, so we will get more than one limits.
yes, like that M case. Okay. So till now I have told you two approaches. One is um, basic classical epsilon delta definition approach to show that limit exists or not, and one is this polar coordinate approach. Okay, and to also show that that limit does not exist, there is a path you can choose, y equal to mx type something depending on m, and the another way is again the polar coordinate, by which you can also show that that limit does not exist. So let me just give you one more question. So this was till now all about the limit case. Now what will be the continuity case if I would say?
Limit should be equal to that point or value at that point, basic.
Yes, yes. So we will do that. Let me give you one more question regarding the limit. Consider the function f from r square to r defined as fxy is equal to x minus 1 whole square y minus 1 whole square divided by x minus 1 whole cube plus y minus 1 whole cube. And here your xy is not equal to 1 1, and obviously if it equal to 1 1, so the denominator will not be obviously denominator will go to 0 and your whole quantity will not be defined. Or whenever it is equal to 1 1, I am defining function as 0. So I am saying if k and l are the limits, if k and l denote the value of the limit lim xy tending to 1 1 fxy along the paths y minus 1 equal to x minus 1 and y minus 1 equal to minus x minus 1 into e to the power x minus 1 respectively, then find the value of kl minus 1 divided by l. So ultimately you need to calculate along these two paths, two limits. One is k defined as k, one is defined as l. then you obviously need to substitute in this equation, or in this you can say um, fraction, then you will get the your answer. Quickly tell me, we have discussed a lot about how to calculate the limits along the path.
So I
Why?
want to see the question. Can you please
Yes, yes, please,
type
sorry.
it little?
It will be it is visible
Okay.
now.
Yes, sir. Yes, sir. Yes, sir.
Okay. Quickly tell me the answer. It's very easy.
Sir, y minus 1 is equal to minus times, and in bracket there is x minus 1.
Yes. Can I rewrite it?
Good. Leave it, sir. Leave it.
I hope it is visible now.
Yes, sir.
Sir, along the path it is 0. Along the path y minus 1 equal to x minus 1. It is 0.
Yes, correct.
Thank you.
1 and minus 2. Sir, let me see the last part of the question. What actually it is finding? K is 0 and L is minus 2.
L is minus 2. No, L, the value of L is wrong.
Minus 2 by 3. Minus 2 by 3.
Minus again wrong. Minus 1 by 3 it is there.
Just basic. Something was there in the power of E. Wait, sir.
Yes, yes. So let us start doing it here also. Along y minus 1 equal to x minus 1 curve. So limit was limit xy tending to 1 1 fxy. So this will come out limit x tending to 1 only, and you just need to substitute y minus s 1 as x minus 1. So you will get x minus 1 whole power 4 divided by 2 times of x minus 1 cube. So from here, limit x tending to 1, x minus 1 divided by 2, that will give you 0. Now the other path is along y minus 1 is equal to minus x minus 1 e to the power x minus 1, this path. So this will boils down to one fxy limit x tending to 1 minus x minus 1 to the power 4 e to the power x minus 1. Let me know if I'm making some mistake. So x minus 1 to the power 4 e to the power 2 times of x minus 1 divide by x minus 1 cube 1 minus e to the power
Sir, excuse me, sir. In the numerator, it may be x minus 1 whole cube, sir.
whole cube.
Yes, sir. In the
No,
given function, you are given x minus 1 whole
So
square.
minus 1 by 3 is coming.
yes, you're right. So here it is square now, both.
Yes, sir. Square.
So minus 1 minus e to the power 3 times of x minus 1. I hope this would be the case. Limit.
Yes, sir. 0 and minus 1 by 3.
Okay.
Yes.
So this will be e to the power 2 times of x minus 1. Obviously there is 1 x minus 1 is here. 1 minus e to the power 3 times of x minus 1. Is this any kind of indeterminate form?
0 by 0.
So what you have to do?
L
Hospital.
hospital.
So by L'Hopital, if you apply, so it will be e to the power 2 times of x minus
Sir,
1.
we can put x minus 1 is equal to t here. It will be simpler.
So obviously we can do that, but we are getting habitual with the our regular approach. Okay, so
Okay.
this will be 2 times of x minus 1 e to the power 2 times of x minus 1 divided by minus 3 e to the power 3 times of x minus 1. So now if you will substitute x equal to 1, what will you get? Did here I made a mistake of minus 1? Here should not be minus. So from here you will get minus 1 by 3. So obviously now you know the value of k, you know the value of L. So this was your k and this is your L. So what is k L minus 1 divided by L? So obviously the first factor will be 0, this will be minus 1 and this will be minus 1 by 3. What will be your answer? Quickly.
3.
3.
Okay. Now let me give you one more question that you will do by yourself, or if you are getting any doubt you will ask, otherwise we will move to the next one if you will able to do that. D2R where D is the domain from R square such that x is not 0 as well as y is not 0 be defined by gxy mod y sin x by y. Can anybody tell me why I'm taking this kind of domain?
Sin 0, 0, sir.
In denominator, it is coming x and y.
Yes, if x and y anyone will be 0, so your function will not be defined. So then calculate or examine, because the limit may or may not exist, na? Examine limit xy tending to 0 0 of gxy. Quickly do this. We have done earlier all type of approaches how to calculate the limit, so I hope you will do it quickly. Shrinu Babu, please. Thank you. Have you done it? First of all, tell me which approach you will going to follow. Can we apply polar coordinate here?
No, sir.
Why?
Basic fundamental, basic definition approach I have used and I got 0.
Okay, correct.
Yes, sir.
See, one person have answered 0 in all paths. See, obviously, if you are saying limit is existing, so you don't need to say all paths. You just need to say what is the limit. Okay. If you are mentioning the path, so that means there might be some case that limit is not existing. Okay. So how you can say that we don't need to use polar coordinates here? I just want to make you clear when you have to use polar coordinates and when you have to when you don't have to use polar coordinates. Can anybody comment on that?
Whenever you see terms like x square, y square, and
X square
obviously
kind of plus
plus
y
y
square.
square,
Yes,
plus y square, obviously,
so that
basic
we can
is
reduce.
generated with a circle. And if you look something like circle, then you can obviously go with polar coordinates.
Correct, correct, correct. So here you obviously have a gut feeling that the limit should exist, so you want to go with the epsilon delta definition. But for knowing the proving the limit, you should have some guess now. What should be the limit? How you can take gxy minus l? So what will be the l? Can you guess it here? What can be that l?
It is by guessing.
So how can you what is the value of that l? Guess you're saying.
It has
Both
no
are
justification.
both are tending to 0, and it is in multiplication with that one. So we can take 0. It's just a basic common sense, or we can take a basic path where also we can find the limit 0,
Manas,
and then we can, by definition, we can prove.
you are saying it correct, but should be precise here with your word. It's not by common sense. It's, you can say it's by intuition. Okay, first of all. Secondly, let me explain. First term, in the first term, mod y is tending to 0, and this is some bounded function. Bounded meaning you are getting that this is the some fixed value between -1 to 1. As I told earlier, sine theta lies, it will be less than 1. So I am saying it is some finite value between -1 and 1. Similarly, this tends to 0, and this is again bounded. So anything number, see, whenever, why I'm saying finite, if it will be case of 0 into infinity, can you say that um, that limit does not exist? That is an indeterminate form. If there will be a case 0 into infinity, is it indeterminate form or not? No.
Yes,
Yes, it is indeterminate form.
we can take infinity in reciprocal.
Yes. So 0 by 0 form you can make. So here you can guess that because of the function sign, I'm saying that whatever will be the inside, obviously if you will see that xy tending to 0 0, it is tending to infinity, but sine function always give you the output as -1 and 1. That's why I'm saying this is some finite value for your intuition to guess the limit. So here it will be 0. So mod y sine x by y plus mod x sine y by x. This is your gxy minus L is 0. So this will be less than or equal to mod y mod of sine x by y plus mod x sine y by x. Now tell me again with the previous thing, this is less than equal to,
1.
so this will be mod y plus mod x. This is your equation number 1. Again with the same criteria, we know that 0 is less than under root x square plus y square is less than delta, and you know that this is nothing but less than under root x square plus y square. So this will be 2 times of under root x square plus y square. Now what will you choose? Your delta again epsilon by 2. Then you will get gxy minus L is less than epsilon whenever your deleted neighborhood, that is 0 less than under root of x square plus y square is less than delta, where delta is epsilon by 2. And what will be your answer? That means, so limit xy tending to 0 0, g of xy is 0. Hence this is your, is there any doubt, anyone getting in following this solution? If it is not, then let me move to the continuity one. So Manas told me earlier also that in one variable, so can you explain why you are, yeah, see, I told you there are two methods to show that that limit exists. One is polar coordinate method, one is epsilon delta definition in this two variable case. Because you have infinite number of paths that I'm explaining again, here the neighborhood have infinite number of approaches to reach this point. So you cannot decide that you can move from the left, you can move from the right. So you need to make it generalized. So either use the polar coordinate, or either you can use the epsilon delta definition. So clearly from the expression from the of the function, you can say that here you cannot use the polar coordinate. Thus we are following the epsilon delta definition. So I hope it is clear now. So let me move to the continuity case. When can we say that our function is continuous in one variable? First of all, our function should be defined at that point. Secondly, limit should exist at that point. And the last one is the limiting value of the function at that point is equal to the functional value. So I'm saying limit, or let me write f x y is, I'm writing directly for the two variables case, so I hope it will be not a problem. Continuous at x naught comma y naught. So if so, this is the case.
এখানে মিনিমাম কত ডলার পাঠাতে হবে কি বললো না?
Vishwajit ji, please mute yourself. The first condition is that your fxy is defined at x naught y naught. Defined means it should have some finite value, then only we can follow the discussion, na? Second point is limit xy tending to x naught y naught fxy exist. And third one is that limit xy tending to x naught y naught fxy should be equal to the functional value at that point. If these three conditions follows, then we can say that our function is continuous at x naught comma y naught. So just these two steps are added, otherwise you have to follow the same approach. You have to calculate the limit and all. So let me write directly the question here. Consider the function f r square to r defined by f x y sine inverse 2x plus y divided by tan inverse x plus y by 2 if xy is not equal to 0 0, mu if xy is equal to 0 0. So the question is find the value of the scalar mu so that f is continuous at 0 0. So ultimately you need to calculate, you know that your functional value at functional value of f at 0 0 is nothing but mu. So you just need to again calculate,
Two.
sorry, yeah, correct answer. So you know that f00 is some value mu. So obviously it is existing, first condition. Second condition, you need to calculate limit xy tending to 0 0 fxy. You need to calculate this one. Then you can equate them and you will get your answer. So now tell me what will be how can you calculate this one? Here is the question. Quickly tell me.
Let x plus y by 2 is equal to t.
Correct, exactly. Earlier someone has also said x plus y equal to t, you can take. So in some scenarios, you can directly get some parameterization like this case. So put x plus y by 2 is equal to t. Now how limit will change? We know that as xy tending to 0 0, it will imply t tending to 0. So this will be limit t tending to 0 sine inverse 2t divided by tan inverse t. Is it correct?
Yes, sir.
Yes, sir.
Again 0 by 0 form. So we need to differentiate it. What will be the differentiation of sine inverse 2t? Tan inverse t is, so you will get 2 times 1 plus t square divided by 1 minus 4 t square. Is it correct? Or I did something wrong?
Correct, correct, sir.
So put t equal to 0, what you will get? 2. Now by the third condition, you want to make sure that this function should be continuous. So limit xy tending to 0 0 fxy should be equal to f of 0 0. What is f of 0 0? Mu. What is the
Mu
limiting value? 2. So ultimately the
2,
value of mu is nothing but
2.
2. Now the case arises, now we can move to the first order partial derivative. So can anybody comment what is first order partial derivative?
Something like you are treating another variable as constant
Yes,
and then differentiating it.
yes. So here in subscript I wrote x. X means I am differentiating the function with respect to x and keeping in mind that other variables are treating as constant. So it will look like this, del by del x. Here we here we do not write d. Here we write this kind of symbol. So this will be of fxy. And what is the definition of this one? Limit delta x tending to 0 0. So let me write it for some x naught
X will be changed.
x naught comma y naught. So this will be f x naught plus delta x comma y, because we are not changing y naught, sorry, y naught divided by delta x. Is it clear? In the similar manner, if I want to write fy, so this will be limit delta y tending to 0. Delta y means just a difference, you can say, just a small disturbance in y naught. Clear? Now let us move to the question. Question number 5. Let r square to r defined by f x y x square sine 1 by y square plus y square sine 1 by x square if x is not equal to 0 or y is not equal to 0. Any case can possible. Any one case can possible out of these two. 0 otherwise. So this is your function given. So also I am saying let fx a b and fyab denote the first order derivative with respect to denote first order partial derivative of f with respect to x and y at AB. Now tell me then calculate fx at 0 0, fy at 0 0, and check the continuity of f at 0 0. See, in general, uh, there might be some function for which your partial derivative may exist, function may not be continuous at that point. I hope my screen is visible now.
Yes, sir. Now it is now.
Okay,
Yes, sir.
sorry for the disturbance. So
No.
we were talking about here we need to comment over this we have to calculate partial derivatives at 0 0, and we have to comment over the continuity of f at 0 0. So please try this one, then we will discuss it. Any answers? So how can we see the continuity? Again by epsilon delta definition. So the sequence will be almost same. So let me quickly do it. Consider fxy minus 0. So this will give you x square sine 1 by y square plus y square sine 1 by x square minus 0. So this will give you less than equal to obviously x square plus y square. Now you know that 0 is less than under root of x square plus y square less than delta. What you need to choose delta equal to? Tell me.
Epsilon.
Are you sure epsilon?
Root epsilon.
Epsilon square, I guess. Epsilon square or root epsilon? Someone is saying something about the screen. Screen is not visible to others.
Visible, sir.
Okay. I think there is some issue at your end. Please check. So we need to take root epsilon. So here it is kind of delta square you are getting here. It is delta square. So obviously delta should be root epsilon. So that we will get fxy minus 0 less than epsilon whenever 0 less than under root of x square plus y square is less than delta, where delta is equal to root epsilon. So therefore f is continuous at 0 0. Now quickly tell me fx 0 0. What will be fx 0 0? Limit delta x tending to 0 0 f 0 plus delta x 0 minus f 0 0 divided by delta x. So what it will give you? Tell me. Limit delta x tending to 0. This will be delta x square sine. Tell me what will you get? Tell me.
Sir, x not equal to 0 or y not equal to 0. What does it mean?
That means either y x cannot be equal to 0 or y cannot be equal to 0. I'm not talking about simultaneously. Quickly calculate it.
It will 0.
Why?
Sine is getting 1 by 0, and f of 0 0 is also 0, and in denominator we have del x, and 1 del x will cancel, and del x limit tending to 0 will give 0 out.
Am I audible to everybody?
Yes, sir.
Yeah. Can you explain
Yes.
again, please? See, I'm saying that x is not equal to 0 or y is not equal to 0. If that case is occurred, then we need to use the first part of the function. Otherwise, we need to use the second part of the function. So tell me why it is 0.
Sine will get 1 by 0.
Okay.
0.
So can
F of 0 0 is 0, and in denominator we have del x. 1 del x will cancel, and when we apply the limit del x to 0, so it will give exact 0.
but here if you will observe that here it is already 0. Can we write like this? I'm just curious to know.
No, we can't write like this. But it is, and wait.
Since we cannot write like this, then how we are calculating? How you are calculating that fx 0 0?
I'm approximating because whatever sign will take input will give output maximum minus to 1,
See,
no matter what the input is. But something I have doubt like it is bounded or
uh,
not at this.
Manas, just wait. Can anybody tell me, confirm me that my internet is weak or his voice is not coming properly? Can anybody confirm?
Yes, it is coming.
Okay, so maybe my side issue. See, I believe here we cannot calculate fx 0 0. I believe. Can anybody agree with me over this? See, we cannot write like this statement. Okay, so obviously we cannot calculate fx 0 0. So we need to modify our question. It should be fx 0 comma b or fy 0 a comma 0. Where obviously I'm saying a and b are non-zero. I'm assuming that. So in that case, this will be b b b. What will happen then? Anybody has any confusion? Please ask me. So what will be the case? If you will see this kind of thing, this will be limit delta extending to 0. Here this is a non-zero quantity. This is also a non-zero quantity. What is the meaning of x not 0 or y not 0? What is the meaning of this?
If any one of them is non-zero, then that one is defined.
It is like union, someone said. Okay, that means sorry, Manas, can you repeat yourself? I missed your, what did you say?
It is saying that if any one of is non-zero, either x or y, then it is defined.
Okay, if both are 0 or any one of the 0, suppose x is equal to 0, then it will be defined.
X is equal to 0 and y is equal to a, b, something like that, then it is defined.
Okay,
Or x is equal to a, y is equal to 0, then it is defined. X is equal to c, y is equal to d, then it is defined.
so this will give you sine 1 by b square plus 0 as y is 0 minus, sorry, it should not be 0, it should be b sine 1 by delta x square. I think there is something wrong in this question, because still we will get some error. Let's see. So when you put f0b, you are taking x to be 0, then which function will you choose? First one or second one? In case of f0b, which function will you choose? First one or second one?
First one.
So f0b, when you substitute 0, then first factor will be 0, but again second factor will create problem. So I believe this cannot calculate even for fx0b also. Anybody has any comment over this? We are saying it correct or
But
yes?
fxy is defined at all points.
Yes, it is defined at all points. I am not
So
denying
why
it.
can't
say it. Biswajit, could you please complete your statement?
If it is defined at all points,
Mm-hmm. Mm-hmm.
you know, why can't we find like f HB or f delta XB or f zero delta?
I am not saying we cannot find, but here it will be sine 1 by 0 again. I am saying this one. So we cannot find for the case we are saying 0, 0. We can find at any point AB. Non-zero kind of point we can find out. I am saying that A
Where
plus,
A and B are both non-zero.
yeah, A and B should not should both non-zero. I believe so. So since this question has some error, so we only leave this to the continuity part of only. Okay, so we will do some other question to understand this partial derivative sense. So let us quickly do the another question so that we don't miss the glimpse. Consider the function f r squared to r defined by fxy is equal to 2x square y x to the power 4 plus y square if xy is non-zero. See, continuity of this function we have seen in the second example. So obviously we will not discuss its continuity here. We only discuss its partial derivative at 0, 0. Calculate fx at 0, 0 and fy at 0, 0. Now quickly tell me its answer.
Fx
Both
zero
zero.
zero is zero.
Correct,
Both zero.
correct, correct.
Both zero.
0, 0 limit delta x tending to 0. Please mute yourself. 0 plus delta x comma 0 minus f 0, 0 delta x limit delta x tending to 0, 0 2 delta x square into 0 divided by delta x to the power 4 plus 0 square minus 0 divided by delta x. So this will give 0. Similarly, fy 0, 0 will also be 0. I hope it is not that much difficult to check for this question. Also, I just make a note here. F is not continuous at 0, 0. So that means there might be some case where function is not continuous at 0, 0, but still its partial derivatives are existing. Now let me give you higher order partial.
Sir,
Yes.
sir, we know that so there might be confusion in my mind. We know that partial derivative at x and y at a given point exist, and if they are same, the function is continuous.
No.
Not always. Then something like this I have studied in lecture in a remarks part. Maybe
That is
there's something one or
that
two
is
word
for
I'm missing.
that is for higher order partial derivatives. Fxy and fyx. I'll tell you in next
Oh
question.
yes, 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 yes. So correct, correct, correct.
If your function is continuous, then you can say that both of them are equal. Consider the function f r square are defined by fxy is equal to x square y divided by x plus y if x plus y is equal to not equal to 0 and 0 if x plus y is equal to 0. Find the value of del square f by del x del y plus del square f by del y del x at 0 0. Quickly do this. I hope it is not difficult for you to calculate this value, because what how we can define f del square f del x del y? Tell me the definition.
Del f by del x or del by del x of del f by del y.
So this will be
And yes.
limit delta x tending to 0 f y of, tell me, f y of
Delta x comma 0 minus fy of 0 comma 0 upon delta
delta
x.
x comma 0 minus fy of 0 0 divided by delta x. Now you can open up the expression of delta x, that's 0. So this will be limit k tending to 0 f delta x comma delta y minus f of 0 0. Is this correct? F of 0 0 of delta x 0 divided by delta y. What will be the second one? Minus,
It will be 0. It will be 0.
I am not interested in the answer. I am just first of all curious how to write this one.
F of 0 comma delta y
Good.
minus f of 0 comma 0 upon delta y.
Now calculate this one.
Let me see the questions a little bit.
Yes, yeah.
One.
Your answer is one, correct.
Huh?
Yes.
Both
Direct
are
partial,
one.
Sorry, can you repeat? Uzair?
डायरेक्ट पार्शियल डिफरेंशिएट नहीं कर सकते ये
See, direct partially differentiate करने से
यू
पहले we should
यू
know that.
बाई वी रूल अप्लाई करके
Yes, yes, yes. In
एक्स
this,
के रिस्पेक्ट में वाई को कांस्टेंट मान के फिर एक्स कांस्टेंट मान के वाई के रिस्पेक्ट में.
can I say it now? See, first of all, here I want to make you learn how to calculate the partial derivatives with the definition. Secondly, in some cases, it might be the case you will differentiate, and after when substituting x equal to 0 or y equal to 0, the function will be not defined. So sometimes there may be the case that partial derivative does not exist. So we need to follow this approach. So let me just do it. Limit.
So the answer is one for both, like finding the value of 1 plus 1, that is 2.
Okay. No, no. For one is it is 0. For other one is 1. So f of delta x comma delta y. What it will give you? Delta x square delta y divide by delta x plus delta y minus 0 minus limit delta y tending to 0. F of 0 delta y will be, this will be 0 and this will also be 0, divide by delta x. The first expression will be limit delta x tending to 0. This will be 0 minus 0 divided by delta x. That will give you 0. Is it clear? Is it clear or any doubt? Did I done anything wrong? Please tell me. If oh, I missed one term. Sorry here. I missed one term here. Nobody is noticing that here there is a division of delta y also. Delta y also. Here is also division of delta y. So delta y will cancel out. You will left with delta x and divide by delta x. So it will give you 1. Next one is f delta square f y x at 0 0. Now tell me, this will be limit delta y tending to 0, limit delta x tending to 0, delta x, delta y minus 0 comma delta y divided by delta x. With the negative sign, limit delta x tending to 0, 0 comma delta y minus f00 divided by delta. Is it clear to everybody? If you are getting any problem, kindly stop me and ask. So this one will be limit delta x tending to 0. So this will be delta x square delta y delta x plus delta y minus, this will be 0 divided by delta x minus limit delta x tending to 0, 0 minus 0 divided by delta x whole divided by delta y. So limit, so this will be limit delta x tending to 0, this will be delta x delta y divided by delta x plus delta y. minus 0 divided by delta y. So from here you will get limit delta y tending to 0, 0 minus 0 divided by delta y. So this will be 0. So at the end, del f by del x del y plus del 2f del y del x 0 0 is the value of this 0 1 plus 0, that is 1. Is it
Sir, I
clear?
have a doubt.
Yes, please ask.
Sir, in first we will calculate limit delta x 0 for delta x into delta y upon delta x plus delta y. So for this, in last slide, sir. Yes, sir, yes, sir. In second line, first we have to calculate for limit delta x tends to 0. Delta x. Oh, it is no, nothing. It is not a form. Okay, okay, sir. My bad, my bad.
Okay. Okay. Can I? Here this was question number 7. Now let me write question number 8. Is here. So question number 8 is consider the function is equal to 1 by x square plus y square plus z square to the power 3 by 2, then find the value of del 2 phi del x square del 2 phi del y square del 2 phi del z square. Tell me. See, I got one suggestion for this question that we are doing here. If we will replace this and this or with and, then we will get our suitable answers for all questions. If we will replace it with and, then obviously this we will end, and then we can calculate 0 0. So this will be nothing but 0 0 0. We don't need to now worry about it. So in case of AND, what will be the value of the first expression? Tell me. Whenever both the terms are non-zero, then only this function apply. Otherwise, if any one of them zero, your function will be, everybody, are you there, Manas?
Sir, was focusing on that question. First, sir, let
See,
me.
first of all, let us conclude this one. Please focus here. I am
Okay,
saying,
sir.
I have replaced this or with and. Okay, so that means whenever x and y both are non-zero, then only this function is applicable. Otherwise, the function will be zero. So in case of f x at 0 0, y is 0. So that means what will be the value of the functional? 0. And this will also be 0. So your partial derivative of x with respect to x at 0 0 is 0. Similarly, if you will try to calculate 0 delta y f of 0 0 divide delta y. So as the function defined, whenever any one of xy is 0, the function will give you value 0, so it will be 0. So I hope now it is sorted. Okay, now you can do that question.
Yes, sir, sorted.
Now you can do this one quickly. Let me also do it. This will be 3 by 2 x square plus y square plus z square to the power minus 5 by 2 into 2x. This will give you 3x x square plus y square plus z square to the power minus 5 by 2. So when you will
Sir,
do it,
you are leaving negative side, minus 3 by 2. This one, minus 3 by 2.
sorry,
Sir,
Minus
here it
3
is
by 2.
minus 3
There
by
will
2.
be minus 3 by 2.
okay, sorry, minus sign will be there.
Yeah.
So now this will become 15 by 2 x x square plus y square plus z square to the power minus 7 by 2 x. This will be minus 3 times of x square plus y square plus z square. Write it in the next line. Please mute yourself. This will be 15 x square plus y square plus z square to the power 7 by 2 with minus sign 3 times of this will give us 12 times of x square minus 3 times of y square minus 3 times of z square divided by x square plus y square plus z square power 7 by 2. Is this clear?
Sir,
Yes.
the answer is 6 upon x square plus y square plus z square की power 5 by 2.
I guess so.
So we can directly see that this is cyclic CT, like x
Yeah,
square,
yeah,
y square, z square. So in next term, in place of x square, there will be y square. And next, in place of y square, there will be z square. And
yeah,
so we can, by just similarity, we can do that.
yeah, I'm doing that. 12 z square minus 3 y square minus 3x square so when you will add all of them what will happen 12x square minus 3x square minus 3x square you will get 6 times of x square plus y square plus z square divide by 7 by 2 6 by x square plus y square plus z square to the power 5 by 2. What is the value of the phi? 6 by 5. It was 3 by 2. Okay. Now you are getting 5 by 2. So what should be the case? Tell me. Is it correct? Tell me.
Correct, sir.
No, it is not. It
No,
should
no,
not.
3 by, you write 3 by.
It should be in the numerator. Because in the phi it was in the denominator now. Any doubt? Or shall I move to the last question? Okay, just let me write the last one. It will be your homework. F r square to r defined by sine x square minus y square divided by x square plus y square. If please mute yourself. Samil, please mute yourself. Samil, mute yourself. Sorry for the disturbance. So this will be xy is equal to 0 0. Now find del f by del x del y del 2f by del y del x. It may or may not exist. You just need to find out.
It's at which point we have to find just x y x comma y
That is a question at 0 0. So find out
at 0 0. Okay.
this and this at 0 0, not their sum, this and this at 0 0. Okay, any doubt?
सर वो फंक्शन आर स्क्वायर टेंस टू आर इसका क्या मीन है?
Sorry, r square tends to r. Okay. This means that domain of the function is r square and range of the function is r. So that means you are putting the value in the function xy, suppose 1 2 2 3, a pair you are putting in inside it, but output is getting a single value, that is a real number. It can be 0 1 2, anything. Understood? So any other doubt? Okay, then let's meet you on next Tuesday in the third problem solving session at the same time. Thank you.